So the last lesson we're going to look at is the second half of 5.3. And we talked yesterday about how to write complex numbers in polar. And the advantage of writing them in polar is it gives us a really quick way to do multiplication, division, and one other thing I'm going to talk about is raising to a power. All right, so let's just quickly review how you do division in standard form. Okay, not using polar. So if I had something like 2 plus 3i, and I want to divide by 4 minus 5i. What's the first thing I have to do here?
Set up the thing.
Okay, so we can put some parentheses around it. And then what? Multiply by the conjugate. And what's the conjugate in this case? 4 plus 5i. Okay, so we'll do all this out. Now in the bottom we have a shortcut. 4 squared and 5 squared. So 16 plus 25. You've been using that shortcut. It's still going to take a little bit to do all this. And now in the top, we've got to FOIL it out. 2 times 4 gives me how much? 8. 2 times 5i? 10i. 4 times 3i? 12i. And 3i times 5i.
15i squared.
It's a 15i squared. All right, so now we're not done yet. We've got to combine like terms. What's 10i and 12i? 22i. And we can change the I squared to what number? So that's really a negative 1 times 15. That's going to give me a negative 15. Right, so I just multiplied 15 times I squared. And in the bottom, we can combine like terms. 16 and 25 gives me 41. All right, and now that I changed the I squared, I have more like terms I can combine. I have 8 minus 15. Negative 7. So that's negative 7 plus 22i over 41. And now we just have to format the final answer properly. It should be written like this. Not one big fraction, but 2 separate pieces, real, imaginary. So just put each number over 41. And that's your final answer. Okay, it's not overly hard, but there are a lot of steps. So now, we're going to look at how to do the same thing, but in polar. So in polar, your 2 complex numbers would be written like this. So remember, each complex number, they usually use the letter Z when we're talking about a complex number. The 1 and the 2 just mean my first complex number and my second one. Each complex number will have its own radius and will have its own angle. So when we do an actual problem, you'll know what the R1, the R2, theta 1, and theta 2 values are. If we want to multiply these 2 numbers together, instead of having to do FOIL and then I squared and change that to negative 1 and combine, all we have to do is 2 things. We're going to take the 2 numbers that are in front and we're going to multiply them together. So we just have to multiply the 2 radii. And then we're going to take the 2 angles that are right there and add them up. And that's it. So 2 very simple calculations. You're going to multiply 2 numbers together, and then you're going to add 2 numbers together. And that takes the place of everything that I just showed you. But it requires that you know how to get a complex number into polar form. That's what we learned yesterday. Okay, so that's the product. And then we'll do, I think I have the quotient on the next page. Let me just see. Yeah, got the quotient on the next page. So we'll get to that. Right, so let's take these two complex numbers and let's find their product in polar. Okay, they're already in polar for us, so that's good. Saves time. We don't have to figure out the r and the theta. They were just given to us. Okay, so let's follow the formula up above. When you multiply these two complex numbers together, what is going to be your new radius? 15. It's the product of the two radii that you were given. 3 times 5. And then the last thing is to fill in the angle. What's going to be our, Ryan, what's going to be our new angle? How much? 120. We just take the two angles we were given and add them up. 120. 120. That's it. That's the answer to what you get when you multiply those two numbers in polar. Any question on that? Now I want to check that. What I'm going to do to check it is I'm going to change everything back to the way we're used to doing it, multiply it that way, and see if we get the same answer. Okay. Let's change this to standard form first. So the way I'm going to do that is I'm going to multiply the 15 out to the cosine and to the sine. So let's start with 15 times the cosine. Okay, so we'll need a calculator to do that. Okay, and we'll probably get some decimals. I'm just going to go to two places. Let's do 15 times the cosine of 120, and that gives me negative 7.5. And now let's do 15 times the sine of 120. 15 sine 120. Okay, so it's pretty close to 13. So I'll do 12.99. So this is also the answer. This is the answer in polar. This is the same answer in standard. So what I'm going to do now is I'm going to change each of these, the original problem they gave me, to standard, so I can check it the way we used to do multiplication, and I want to see if I get this number. Okay. So all we're doing now is we're just checking to see if we can get the same answer. I'm not going to do every problem like this twice, just the first one to show you that this works. So let's change z into standard. So I need to multiply 3 cosine 20. 3 cosine 20. That gives me about 2.82. And 3 times the sine of 20. 3 sine 20. That gives me about 1.03. So numbers are going to be a little off, but they should be close. Okay, so that's the number they gave me in polar. That's the same number they gave me changed back to standard. Okay, so the second number, that's what they gave me in polar. And now I'm going to make it standard. 5 times the cosine of 100. That gives me negative 0.87. And what do I do to get the last number?
5 sine 100.
Yep, 5 times the sine of 100. I'm just doing it out. 5 sine 100. Okay, 4.92. Now, let's multiply those two numbers together the way we learned yesterday, and let's see if we get about negative 7.5 plus about 13. 2.82 plus 1.03i times that. Okay, what's the first two numbers we multiply together?
2.28 times negative 4.87.
Yep, so we'll multiply those two. So 2.28 times negative 0.87 gives me about negative 1.98. All right, and what's the next two?
2.28 times 4.92i.
All right, so let's do 2.28 times 4.92. 2.28 times 4.92. That gives me 11.22. 11.22i. Jaden, what would be the next two I multiply?
1.03 times negative 12.87.
Yep. So let's multiply those. 1.03 times negative 0.87. I'll just say negative 0.90. Negative 0.90. All right. Oh, I. And then the last part, 1.03 times 4.92. 1.03 times 4.92. Okay, and that gives me 5.07 I squared. 5.07 I squared. Okay, well, let's combine like terms and see what happens. So when we combine, this is 11.22, and then we're subtracting 0.9 from it. That did not give us 13. So one of two things. I either made a mistake with one of these numbers, or I made a mistake with that number. Anybody see where we might have made a mistake? I don't think I did. All right, so we fixed the mistake. Our mistake was we put down 2.28 instead of 2.82, so we had just switched two numbers. All right, now let's combine like terms and see what we get. So negative 2.45, and then I'm going to add 13.87, and I'm going to subtract 0.9. So 13.87, subtract 0.9, and I get 12.97, and over here I get 12.99, just because of rounding. And I squared is what number?
Negative 4.
Yep, so this is minus 5.07. So let's combine the negative 2 and the negative 5 and see what we get. Negative 2.45 minus 5.07 gives me negative 7.52, and we had negative 7.5. Yep. So we do end up with the same thing. So you can see just from doing it in standard form, there's a lot more steps, and even for me, it's very easy to make a mistake because there's so many steps and you're copying numbers over. You could just do something real simple and reverse it. But when you're doing it in polar, there's not as many steps, so there's less chance you make a mistake. Okay, any question on that? Okay, so from now on, if I can just stick with polar, I'm just going to do it that way. I'm not going to do standard. Okay, let's try this one. So find the product. And the two numbers we're going to multiply this time are 1/2 cosine 15, I sine 15, and 10 cosine negative 30, I sine negative 30. Okay. When we multiply, what's going to be our new radius?
5.
5. I'm going to take the 2 radii right here and multiply them. And what's going to be my new angle?
Negative 15.
Yep, take these 2 numbers and add them up. So 15 plus negative 30 is negative 15. Okay, now that answer is fine. We did multiply, we did what they said. But if they wanted a positive angle, what would you do to the negative 15?
Negative 345.
Right, you'd add 360 to it. And this is how you could write your answer with a positive instead of a negative angle. Just change the negative 15 to 345. These are the exact same answer mathematically. It's just this one's written with a positive angle, that one's written with a negative. Any question how we got the positive angle? Okay, so way easier to do it in polar. All right, so the 2 steps, multiply these radii, add these angles. Okay, let's look at division. Okay, when we have division, what do you think we're going to do with those 2 numbers this time? We're going to divide them. So it's going to be R1 divided by R2. And what do you think we're going to do with those 2 angles? We're going to subtract them. Yep. So by dividing 2 numbers and subtracting 2 numbers, those 2 steps take the place of everything that I showed you right here. All of that goes away. But again, it requires that you understand how to do polar instead of standard. So let's try one of those. Okay, so here's 2 complex numbers, Z. I could call the numbers Z1 and Z2. I could call them Z and W. What you call them doesn't matter. What's important is the numbers, the 3, the 75, the 5, and the 30. All right, so Kim, when I divide these 2, what's going to be my new radius? We can leave it as a fraction.
3/5.
Yeah, just leave it as 3/5. 3 over 5. Okay, so my new radius is 3/5. And what's my new angle going to be? 45. Take your 2 angles and subtract them. And the order you subtract them in is important. Always start with the angle in the top and then subtract the angle in the bottom. 75 minus 30. Okay, and as long as I didn't make any mistakes, I could change all of this to standard form, go through it like I did last time and show you it would come out the same, but we already did that once. So. Okay. Any question on that one? Great, so one more of those. And we will write our answer with a positive angle if that situation comes up. All right. So they want you to take Z and W and divide them. Okay. What would be your new radius? How much? 20, yes. You're taking 10 and you're dividing by a half. Okay, some people at first they say 5. Well, you're not dividing by 2. You're dividing by a half. So your new radius is 20. And Serenity, what would my new angle be?
-8.
Yep, so the 20 minus 100, that would give me negative 80. And then what can I add to that?
360.
I can add 360, and that's going to give me 280. Okay, so that's my angle. 280. I sine 280. And we got that from negative 80. We added 360 to it. Okay. Any questions on that? Now, when I left my final answer like this, is that standard form or is that polar?
Well,
That's polar. And it's fine to leave your answer in polar because they didn't say you had to change it to standard. If I wanted to, I would just distribute the 20 out, and that's how I would change it. So that's multiplying and dividing. And let's try one more with multiplying, but let's try this one. I'm not even going to make the numbers that big. 2 plus 3i cubed. Now, is that standard or is that polar?
standard.
That's standard. What does it mean to cube something?
You have to repeat it like 3 times.
And when you repeat it, what operation are you doing?
Multiplication.
Multiplication. So this means to do this. That's 2 plus 3i cubed. You don't just cube the 2 and cube the 3. There's more to it. Okay, you have to write the same thing 3 times, and then you have to FOIL it. Okay, so this one's only cubed, so we'll do it by hand just to see how it works, and then we'll get our answer. Okay, so let's start with this one and this one. 2 times 2 is going to give me 4. What's 2 times 3i?
6i.
And another 2 times 3i?
6i.
Another 6i. So that's 12i. And what's 3i times 3i? 9i squared, which is really what number?
Negative 9.
-9. Okay, I'm going to simplify. 4 minus 9 gives me -5. And that's what you get when you multiply the first 2 together. But we still have one more 2 plus 3i to do, and that's the last one. Okay, so that's going to give me -10. What's -5 times 3i?
Negative 15i.
Okay, I'm just going to put that off to the side. How about 2 times 12i?
24i.
24i. If we take 24 and we subtract 15? 9i. Yep. So 9i. And what's 12i times 3i?
36i squared.
And what's 36i squared?
Negative 36.
-36. Combine like terms. -10 and -36. -46 plus 9i. Okay. So to cube that, I mean, maybe it took us, I don't know, like a minute or 2 minutes, I don't know, roughly. Any question on cubing? Okay. So now, let's do 2 plus 3i to the 43rd.
No, thank you.
What's that?
No, thanks.
No? Why not?
Take a long time.
That's going to take a long time. You're going to have to write 2 plus 3i 43 times. And then you're going to have to FOIL it all together. And there's some shortcuts you can use. But it's still going to take a long time. And the chances of making a mistake pretty good. Because you're going to probably have hundreds of multiplications, additions. You're going to make a mistake if you try to do that in standard form. So we're not going to do it in standard form. We're going to do it in polar. If you do it in polar, it doesn't matter if you raise it to the 4th power or the 4,000th power. I can do either problem just as fast. But I have to do it in polar. So raising numbers to powers in polar is even more of an advantage than the 2 forms I showed you right here. The dividing and the multiplying. Yeah, polar saves a little bit of time here. But polar saves way more time when you start doing powers. Because powers can take a really long time if you had a big number. All right. So if we want to raise a complex number to a power, there's 2 calculations we need to do, just like the other formulas. First thing you do is you take the radius that they gave you and you raise it to the power that they ask you to. So you raise the radius to the power. And the second thing you do is you multiply the angle by the power. Those are the two steps. By raising a number to a power and multiplying an angle by a number, that's going to replace, like if you had to do to the 43rd power, that's going to replace writing 43 sets of parentheses and then doing all the formula. Okay, that one formula. Okay, so I'm not going to do something as big as the 43rd power. I'm just going to raise something to the 8th power. But even to the 8th power, if you had to write something with 8 sets of parentheses, it's still going to take a little bit of time to do that. So I want to raise that number to the 8th power. And it's already been put into polar form for you. 3 cosine 20 plus I sine 20. Okay, so let's write it out, raising it to the 8th power, and then we'll use this formula to do it. I don't know if I pronounced the name of the formula, but that's pronounced de Moivre's theorem. That's how you pronounce it. All right, so here's the number they gave us. The 3 and the 20, again, that's given to you. That's part of the problem. And we're going to raise that entire number to the 8th power. So what's going to be the calculation? We might need a calculator. But how are we going to figure out the new radius? Right. Take the radius and raise it to the 8th power. Okay, we'll do that out. I mean, it's going to be a big number, but it's not going to be like in the trillions. So we'll do that in a minute. And what's the calculation for the new angle?
20 times 8.
Right. Take your angle and multiply it by the power you were raising to. 20 times 8. I'll write it like that for now, so if you look back, you can see how we did it. 20 times 8. 20 times 8. All right, let's do 3 to the 8th. So 6,561. I mean, I would say if the radius comes out to a number that's 4 or 5 digits, like in tens of thousands, we'll do it out. If the radius starts to come out to a number that's in like the trillions, no, we wouldn't do that out. We just leave it as 3 to the 8th. And how about my angle? What's 20 times 8? 160. Yep. And that's the answer. So raising 3 to the 8th power and multiplying 20 by 8 took the place of having to put 8 sets of parentheses and FOIL everything out. Any question on that? Okay, so that's the last thing that we're doing with the polar form of a complex number. Okay, so the homework on page 333. So it's 33 to 37 odd, and then 41 and 42. They ask you to do something and change to standard, but I'm telling you, you can leave it in polar. Okay, so I'll leave that up. You've got about 25 minutes or so please use the time to work on that. And I'm also going to put a list of test topics on the board. And once I do that, I'll ask if there's any questions. I can clarify what I mean by a certain topic or show you an example. Okay, so just give me a minute.